Okay, welcome back everyone. Now I want to talk to you about the significant figure rules themselves. Okay, we're going to talk about uncertainty a little bit more. I want to talk a little bit about last time, but I really want to go through the rules. They're not bad. Okay, I'm going to try to present them in a way you haven't seen before. So first things first, this is refresher from last time. Any measurement you make ever, from whether it's measuring out milk into a cup or measuring the mass of something on a scale, measuring the volume of something, is filled with uncertainty simply because the measuring devices we use are not capable of reflecting huge or exact numbers. Okay? And it certainly depends on what instrument you're actually using in this process. Now, for example, a common laboratory scale, like you might see here, has only two decimal places on this. Any number you get from here will have an uncertainty of plus or minus 0.01 grams. Okay, just to touch up on that one more time. So if I have a number, right, and remember the number last time we measured something that had a number like um, 1.92. If I actually made this measurement on this scale, the very last number here is the number that is the most uncertain, the number we're the least sure of. That digit is what's called the estimated digit. Okay? Okay, I want to move on and actually talk about the sig fig rules now. Let me clear the screen. Okay, first sig fig rule is here. By the way, if you haven't figured out, we abbreviate these as sig figs. Here it is. We take any non-zero integer is always going to be referred to as significant. What's a non-zero integer? That's basically any number between 1 and 9. Okay? Zeros are going to be the exceptions. Those are the ones, the oddballs, the ones we're going to have to pay attention to. So what's an example of that? If I take a number like 3,456, it has 4 non-zero integers. Every single one of them is going to be significant. So this number is going to have 4 sig figs. The following number, 7.35, well, it has 3 integers, 3 non-zero integers. It also has to have 3 sig figs. So I think this rule is the easiest to understand. Anything that's an integer is going to be significant. Okay, it gives you kind of a head start in calculating these. Okay, second rule. Second rule deals with zeros. This rule is specifically talking about leading zeros. These are zeros at the very beginning of a number. These zeros are not significant. They are not counted as significant figures. Let me give you an example. Okay, here's a perfect example for you. This is a number, these are what we're calling leading zeros. These are zeros at the beginning of a number. There's nothing that comes in front of them. There's no integer that comes in front of them. They're leading zeros. They are not significant. But these 3 integers are. So this number as a whole, even though there's 5 figures here altogether, only 3 of them are significant. Here's another example of the same thing. 0.01. Both zeros at the beginning of the number are leading zeros. 1 sig fig in this number. How about this? 0.1. Same thing. The 0 out in front is a leading 0. It's not significant. This number also has 1 sig fig. Okay? There is a supplement to this rule. We talked about zeros at the beginning of a number here. Now we have to talk about zeros at the end of a number. We call these trailing zeros. Trailing zeros are never significant unless they come after a decimal point. That's the key. A 0 that comes after a decimal point. It has to be at the end of a number. It's got to be a trailing 0. It can't be a leading 0 like this. What we have here, this is a 0 that comes after a decimal point, but they're the zeros at the beginning of a number. They're leading zeros. So these are not significant. Okay, let's give you an example of what we mean here. Okay, here it is. The number 3,700. We have how many integers? 2. Do we have any leading zeros? No. Do we have trailing zeros? Yes. 2 of them. 2 trailing zeros. Do those zeros come after a decimal point? No. So how many sig figs can we have? 2. Okay, let's try another one. This one's a hard. Okay, how about the number 140? Okay, go with what you know. Integers, we have to have 2 of them. Good, at least 2 sig figs. Do we have any leading zeros? Are there zeros at the beginning of a number? No. Do we have trailing zeros? Oh, yes, there's 3 zeros at the end of a number. In fact, these 2 get caught at the very end. This one is a special case. This is what we call a captive zero. This is going to come up next. This number has 5 sig figs. Okay, that last example we did brings up an interesting rule. This is the last rule we have to worry about. Captive zeros. What's a captive zero? This is a zero which is kind of caught between, whoops, wrong one. This is a zero that is caught between 2 integers. So there's my integers, the 6 and the 7. The 0 is caught between them. Does it follow the trailing 0 rule? Sure, it's a 0 that comes after a decimal. Is it a leading 0? No. Caught between 2 numbers. You got a 0 that's caught between 2 integers, you have yourself a sig fig. This number has 4 sig figs. So people, those are the sig fig rules. Okay? Okay, just to refresh the sig fig rules one more time. Any integer is significant. Leading zeros are never significant. Third rule, captive zeros are significant. These are zeros that be in the middle of a number. Trailing zeros are significant only if they come after a decimal point. So let's take a look at those rules here. What do we have? What do we have here for zeros? These are leading zeros, not significant. Integers, I have 3 of them, 3 sig figs at least. But what about this 0? This is a trailing 0, and it comes after a decimal point, and it comes after an integer. How many sig figs? 4. Next one, 100. At least 1 sig fig. These are trailing zeros. You see a decimal point? Neither do I. This number? 1 sig fig. Okay, 101.05. We got tons of captive zeros here. Captive 0, captive 0. This could also follow the trailing 0 rule. So this one, 5 sig figs. Last one, at least 2 here. This is a 0, which is, you kind of call this a captive 0 in a way. 0 at the end of a number after a decimal point, after an integer, also 4 sig figs. Okay, these are the sig fig rules. We're going to be spending a lot more time in class practicing these. These are not something which you get overnight. I wanted to try to make this video short. The next time we come, we'll have a video on multiplication, division, and addition, subtraction. Okay, see you later.